Good evening, everybody. So, I welcome everyone for the innovation session today. So, I'm Keith Sugadasa. I'm working in Team Foxtrot. And the topic for today is cybersecurity and cloud computing. So, I chose this topic in the last moment because it was something interesting that everyone wants to know how cloud computing and cybersecurity can be attached together and see the aspects that we don't actually see in our real life. So I'll just move on with the agenda for today. So mainly we'll be talking about the basics in cybersecurity. What is cybersecurity, how this is being modeled, and what are the basic concepts. Then crypt analysis, how ciphers and passwords can be cracked easily and the ways that they can be hacked that we don't know of. Then computer hacking. So hacking is a very, people consider it as a bad thing, but there are good parts of it as well. So we'll be talking about that as well. And then cloud computing architecture, the basic architecture. Then the cloud security, the aspects of security when it comes to cloud. And the notorious 9 threats in cloud computing. This is a very famous thing when it comes to cloud computing security because people know that there are issues like this, but they have been ranked as the top 9 issues that people face when it comes to cloud computing. And then we have AWS cloud security, because I know in Cisco Labs we all use AWS, but we don't really realize what's the responsibility we hold and AWS holds apart from just having security tools. So, cybersecurity. When it comes to the term cybersecurity, it does not really mean just software. It could be even hardware, it could be even data. So data breach can also be considered as a cybersecurity threat. So what we call by cybersecurity is a set of best practices and methods that people use to secure a computing device, or maybe a set of computers, a server, or even a mobile device can be considered as cybersecurity. So the threats that a device like this can have is simply a denial of service, where you're trying to use, let's say, Google Docs, and the service is down. This could be a hack. If you go to the supermarket and pull out a computer plug, that's a hack, because you're taking the system down. If you leave to the washroom with your laptop open, even one of your friends can hack your computer. Even that's a hack. So these are considered as cybersecurity issues. So the main thing is there are security standards. So whatever software we take, whatever institution, whatever hardware device, there's a level of security standard. So when you're building softwares, let's say you're building a mobile application, which is taking your SIM card as, let's say, as a security authentication mechanism. So this could be GSMA or whatever it is. They have a level of assurance. They say there's LOA 1, LOA 2, because these are trust levels. If you have a higher trust level, there are many clients coming into application. That's how the trust is being built in these applications. And then we'll be talking about best practices when it comes to security aspects. So these are just basic concepts. I'll just brush through this very fast. So when it comes to attacks on security, one thing is there can be an interruption. For example, if you take a banking application, your system can be interrupted. You try to access the bank login, but it's being interrupted in the middle. Or else it can be an interception as well. You are accessing the service, but in between someone else is capturing the packet. So this is an issue as well. And then there can be a modification. Yes, true, you're going straight to the bank login, but in between someone else is taking that packet, modifying it, maybe regenerating it, and sending it to the bank. But you actually see that it's going to the bank, but in between there's a man in the middle. And then fabrication. You are not doing anything at all, but maybe in the morning, early in the morning, at 3 a.m., someone is issuing a request under your name, and that's not you, but someone else. So these are the basic 4 concepts how attacks can happen in terms of security. And then this is called the CIA in computer security, where if you call your application or a hardware device or even a company, a secure company, you should have these 3 basic concepts. Confidentiality, there should be privacy. In whatever data you take, there should be privacy. And then integrity. People should be able to trust you. Let's say you make a request and you get some data back. You get your bank account details. Can you really trust that information? That comes with integrity. So that should be a part of security. And then the availability. So people might think this is a, I don't know, quality engineering aspect, availability, but that also comes under security. If you're trying to access Google Docs or maybe Google Slides, if that is not accessible, that could be a security threat. So that comes under a part of security. So these are the basic concepts of cybersecurity. So let's move into something interesting, crypt analysis. This is where you analyze and break encryption schemes. This is something very interesting when it comes to the industry of computer science, because people break passwords just like that in a snap. And this could affect millions and millions of lives. So everyone here has an Office 365 account, right? So whenever you log in for the first time, you are asked to change your password. So when you change your password, I myself have faced it like 5 times. They are saying, change your password again. It's not random enough. Change it again. So I use my common password. It's again coming as the same thing. Change it as a random password. Why is that? Because Microsoft considers dictionary attacks very serious. What is a dictionary attack? A dictionary attack is they try and hack your password. They try and crack your password using common words that come in the dictionary. They do a basic search on you, identify the common words that you might be using, and then do a brute force attack using the dictionary words. So that is a risk, and these things should be avoided. Examples like I'm the best, I love blah blah. So examples like that. And then the other thing is brute force attack. So this is something that cannot be avoided unless you are using a longer password. The only way you can avoid is by using a long password. It's like you include dictionary plus non-dictionary words and try and crack your password. Whatever password combination you put, they will go through all the possible combinations and then try and get whether your hash is matching the actual password hash. So the concept here is, whatever you use, let's say this AAAA901. So this is a character set of 7 characters. If your password is, let's say, 1 character, and there are 100 possible combinations, so that will be 100 times your password. So there can be only be 100 combinations. But if it's 2 characters long, then there can be 100 to the power of 2 combinations. So that means 10,000. Likewise, if your password is 6 characters long, that will be 100 to the power of 6. So that means there can be more combinations. So if someone is trying to attack on a brute force attack, that will be very hard when it gets longer. But some websites I have seen where they restrict your password to say, have it between 6 to 8 characters. Is it really a good practice? A person can easily hack unless you have something stored like cookies, or maybe track them down by looking at the number of attempts you have done. But those things are avoidable. Those are client-side attempts. You can simply clear them off and try again. So passwords, the longer, the better, as long as you can remember it. And then this is something new. Like this is, I don't think anyone is aware, maybe some, but this is called a rainbow table attack. This thing needs a lot of processing power. Why is that? Because they have a table of all the hashes. Let's say there's a combination like B and TS. They keep a table with all these combinations. So with all these combinations, you simply have the correct password. So what they do is, all these passwords, when you store it in a client-side application or a server-side application, you hash it. So what they do is, they use the hash and check whether there's a matching hash in this table. If there's a matching hash, yes, you can simply directly detect the password using the table. But the problem is these tables are very huge. So if you are trying to use a rainbow table attack, that's going to be very hard. But there's a way you can avoid this. The only way you can avoid this is by adding salts. If you add a salt is a set of characters that you generate from hash function or whatever function and add it to the ends of the password. Then it's very hard to crack that, because even if you get a hash and you try to reduce it to the correct password, that's not the actual password you're getting. So then you should also crack the salt to get in order to get the correct password. So that makes it very tough when you use salts. So this is something that should be done from the application provider, service provider, not by us. So that's a rainbow table attack. And then phishing. This is something very famous and that happens a lot. Now, my friend, I was talking with him before, and he said that Facebook Messenger has stopped phishing attacks, allowing phishing attacks to be transferred through Messenger. So that's a good thing. Like if you send something fake, if Facebook detects, I think they have an AI or a algorithm that identifies and detects the fake links. So if there are fake links, they will identify it and then they will not allow it to go through Messenger. So this is basically phishing is somewhere where you get an email saying, okay, this is from Facebook, enter your login details and we can log into your system. You get an email like that with an embedded window. So what you do is you enter the details there and then you get hacked into a different account. Maybe you will directly go into Facebook. That's a different story, but in between someone else is capturing the data. So this is happening to phishing attacks. So the interesting concept is these things come through messages, but in reality, these things can also happen through humans. This is called social engineering. I can simply walk up to Shiran and ask, what's your Slack password? Maybe not intimidating enough. Maybe I can be more intimidating. I can ask, like, okay, now we are trying to change the servers. Like, let's say we are moving from one drive to a different drive. So what's the mail that we got today? And some tech guy is calling you and saying, we need your password, we'll provide you with a new password, it's like this, blah, blah, blah. So when you go into a situation like that, there are instances people might actually provide the actual password. So that's a risk where when you provide something like that, like it's like this. Here the example given, you can call a person posting that you're from HSBC, from NTB, or maybe you're the security tech guy. You can post someone like that and get your actual credentials. So phishing and social engineering go hand in hand, but social engineering happens in real time, in real life. So before moving into this, I would like to emphasize the fact where I actually hacked into a Facebook account, not by any brute force attacks or anything. One of my friends, when I was working back then, one of my friends, she had this security questions. So she had put what's her pet's name. So I wanted to hack. I said I forgot my password. I put her email. I went through and they asked for the security question. So security question was, what's your pet's name? I knew her pet's name. So I simply entered that and voila, I got the access straight away. But because they had a lot of steps, they asked whether you have forgotten your email address. Then I said, I don't have access to my email anymore. So simply by clicking on a few steps, and if you're a personal friend and you know the details, you can simply hack into those accounts as well. So I saw this article when I was preparing this slide. Never use security questions. Unless you are sure and maybe it's a very secure question, don't use security questions. Even your family members can hack into your accounts because they know the answers for your security questions. So unless you are very sure about it, do not use it. That's just my opinion and what I saw on the net. So let's go into computer hacking. Does anyone know what this is or who this is? Yeah. So it's called anonymous. It's called anonymous for a reason. It's a group of hacktivists who basically hack. So this started out with, I can't remember the names. There were two main people, who started this group. This group is still there. So what they do is, this started in 2008, where they actually recruit hackers. So if you are interested, you can go to the dark web, sign up with them, and then maybe show them that you can hack something, and then get yourself registered. So this is a very famous group. They represented good, and they represented bad. So what happened was, they actually hacked some ISIS accounts. They hacked like 30,000 to 40,000 ISIS accounts and gave it to the US government. On the other hand, they also hacked the US election systems as well. And some company in Russia, I can't remember the entire story, some company in Russia actually threatened them and said, this is just a bogus group, they can't do anything or something, and then they hacked into that company accounts and broke like many company accounts and showed them what they truly can do. So it's a very powerful group, but then later on, people started getting caught. Many people went to jail, and two of the main initiators of this group actually came to Sri Lanka last year in October. So Anonymous, for some of my friends, went and met him, and now they are the richest security consultants in the world. How did they turn into them? They were bad hackers. Bad, maybe for a good reason, maybe for a bad reason. But from being hackers, they are now good consultants. I'm not sure of the story because they came to Sri Lanka and checked some of our government websites and said that there were around 30,000 faults in 4 to 5 websites in the government. So there was an incident like that as well, but our government doesn't take these things seriously. So let's move on to the hacking technologies. So if you look at Trojans, a Trojan is just like an apple. Let's say not an apple, okay, let's say like grapes. You see it as a nice fruit, but when you try and eat it, you get all the seeds, and maybe if it's, I don't know, rotten, you will get a bad taste. So the actual thing is where you see something nice, you see an actual thing, but inside it's not what you expect. Something that is hidden and something that is trying to capture and get your credentials. So that's a Trojan. It comes from the famous Trojan horse concept that Troy used to get into this kingdom. And then we have backdoors. So Trojans is one thing. Backdoors is another thing that people use to maintain access. You hack into an account, but maybe in future you want to hack again. So what people do is people leave a certain link or a remote URL that you can actually come back and log into. So it's like a house and you have a backdoor open. So whenever you want to log in, you just don't come in the main route, but you come in a different route and then hack into the same account as well. So that's called a backdoor. That's another method of hacking. And the other thing is sniffers. For you to be a sniffer, you should be like hacking into the network system of a certain company or certain service provider. So sniffing can be done with tools like Wireshark, and so yeah, Wireshark can actually capture packets. So that's a network tool that can capture packets and analyze packets. So you can use something like that as long as you have access to the network. So it's like a man in the middle who sniffs for it's like eavesdropping. They listen to your conversations, they look at your packets transferring through the network, and then capture them and get the relevant information. So that's another way of hacking. And then you have rootkits. The term rootkits has come up with the concept of Ubuntu. In Linux, you have the root, the privileged access, and then kit is like a set of tools. So it's like a set of tools that you integrate itself into the operating system. So whenever we try to detect something like this, we will never see that it's a rootkit attack. Why? Because we see that it's already a part of the operating system. So what we feel is, okay, it should be the operating system. If we delete this, the next time the computer won't restart. So there are problems like that. So we don't actually delete these things, but these are very dangerous. And of course, exploits means simply vulnerabilities that are exploited outside. What you can see when you log into a system, maybe if it's going to different redirections, different websites, you can simply exploit the weaknesses in those websites and capture the relevant hacking technique. And then buffer overflows was a major issue in the recent history, where the concept of buffer overflow is in every whatever data structure you use, there's a buffer given. So let's say you have been given 1024 kilobytes. If it goes beyond that, sometimes it might go to the other memory location. This is called a buffer overflow. When you overflow the relevant buffer given to you, you might be writing to some other memory location. So if something like this happens, you can actually access the memory locations of some other application and hack into those applications. So that is the technique of buffer overflow. And then we have SQL injection, which is a very famous one. I know everyone knows about SQL injection, so I'll just simply move on. So this is just a basic idea that I got from the net, where you have the 5 phases in computer hacking. So the first step is people do the reconnaissance. That means they gather information. If I want to hack into my friend's account, what I'll do is I'll Google about him. I'll check where he's going, whatever time he's accessing his networks, is he available online at this time. So I'll do a background search. And then I'll start scanning. After I get all the relevant information, I'll start scanning. Maybe I don't know, check his computer. I'll scan through the devices that he uses. And then finally, I'll gain access through a weakness. After I exploit the weaknesses that he has, I'll gain access to it. And then I'll put something like a Trojan or a rootkit or a backdoor and maintain the access before I leave. And finally, I can cover the tracks. I can alter log entries, removing alarms. I know you guys have hacked into Facebook accounts. How do you cover tracks? You simply go into the activity history and clear the activity history. So that's a way of covering tracks. So these are the 5 phases in computer hacking. And these are 3 hacker classes where you call black hat, gray hat, and white hat. So white hat are the consultants who actually do it as a part of a job. Gray hats actually do it for leisure time, during the leisure time, but they try and identify a weakness. If they identify, they'll inform the relevant authority, or else they'll just leave it. So they don't have a malicious idea of actually hacking and getting the data. And black hat is the ones who are having the malicious ideas of actually hacking into the data and getting them out. So this is a simple step. I'll just skip this step because of the time. This is how you conduct ethical hacking. If you're going into a company or if you are given a product to check the security aspects, you can simply do these things. And so I'll just skip these things. These are just basic ideas. And this is something important. When it comes to legality, in terms of computer hacking, in Sri Lanka, we initiated this in 2007, the Computer Crimes Act. In other different countries, there are different acts in terms of cybersecurity. So you should be aware that you can download movies in Sri Lanka using torrents. But if you try this in US, they will capture you through the IP. The IP will capture through the whatever the network they are using, ISP, and through the IPs, they'll send you a ticket to your house saying, you have been violating these things, so you're charged for these things. So similarly, these things, the legality is different from country to country. So that's all for the hacking section. So if anyone is interested in hacking a website, let's say you want to just try SQL injection, try with something very simple, maybe a personal website or maybe the president's website. You can start with something simple and then move forward. So we'll just talk a little bit about the cloud computer architecture. So when I entered university, I had heard about this cloud computing, but that was simply something like magic to me. But now it's kind of getting clearer, because cloud computing is just another computer somewhere. The only concept that you call cloud is that you access it through, I don't know, a remote link or some other technique. So that's the way you access another computer, and it's called cloud computing. So you simply have the resources, and through the resources, they are being virtualized. You don't actually get the real resources. The cloud providers are handling the host computer. It's like virtual machines. They're handling the host operating system. They're handling all the main parts. And we are given a guest operating system. Through the guest operating system, we are doing everything. So basically, we can get it as a software. We can get it as a platform or even an infrastructure. Maybe we can see it as a complete hardware set where we can do anything we want. So that's the service models, and this can be deployed using different techniques: public, private, hybrid, and community versions. So these are the three service models that I explained: infrastructure, platform, and software. These things, I of course know that everyone knows these things. So I'll just move into the security aspects because that's the main part of the slides. So if you look at cloud security basics, so what is cloud security? When we consider cloud security, so as I mentioned, cloud is just another computer. So if you are thinking of security, there are two aspects. One thing is the actual security of that computer that I talked about. And the other security aspect is how you access that computer. So those are the two security aspects that you have to worry about: how that relevant computer is being protected and how you are accessing that computer. So it's basically like hardware and software. If you look at this, this is the basic standard of how data centers are being secured. There are different layers that have different standards of security. If you look at the Google data center or maybe the Facebook centers, and all these data centers, what you see is at the very outside level, you see a military graded security. And then when you go inside, there are biometrics and other sort of, and even when you go into the server room, they always disinfect you and take you inside because you might damage the, I don't know, the computers there. So they go into that level and then get you inside those server rooms because they consider security as a must. So this is the only security that most cloud providers provide. The rest of the security is up to us. The advantage of using cloud computers. So you can simply use a cloud computer or a personal computer. The advantage of using a cloud computer in terms of security is they regularly update their standards. There are security standards that they maintain. But if we're doing it in our personal computer, we don't even update our virus guard. So that's a thing when you come into cloud computing, they normally update their standards and they have separate security tools. So since everyone is using AWS, you guys must be knowing about IAM policies. So they update all this. There are security tools that you have for this. And then confidentiality is secured. And then finally, they avoid this thing called the DDoS mitigation. So mitigation means reducing it. So DDoS attacks means simply you are making a website unavailable. DOS means denial of service, DOS, and DDoS means distributed denial of service. So how can you deny a service? So you can simply do a Smurf attack or a similar attack and take down a website. Individually, you can do that. You can open up 10 terminals, send out certain packets, heavy packets, and take down the website. But when it comes to the power of cloud computing, people can use the cloud as a supercomputer, as a distributed computer, and do a distributed attack. How this happens is the attacker sends a malicious software to a set of thousands and computers. So once you send to all those computers, they act as bots. So these computers, then after that, attack a single website. So let's say 30,000 bots are attacking a single website. When this happens, that means that website is definitely going to go down. So all of this comes with the cost of performance and cost, the actual money. But then again, people use this when they're in competitive situations, and some people actually do it for fun, for testing. And there are many instances where people take websites down in terms of competition. When they feel that there's another competitive website, they take it down using a DDoS attack. So cloud computing can actually secure that because they have firewalls and relevant ISP security levels where they block all these inconvenient packets coming in. And then in terms of key security aspects in the cloud, we have network security. That's just the basic firewall. Everyone knows about the firewall. So we can simply have a firewall and guard the network. So that will check the incoming and outgoing packets, scan them. If they are irrelevant packets, they'll be blocked. If they're relevant packets, they will actually retransmit using their own protocols. And then configuration management. When you go into the cloud, whatever cloud you're using, Azure or AWS, you will simply come through this configuration console where you can go and do a timeout, maybe set passwords, maybe set access policies and those things. And you have a configuration management section where you can configure the management. And then data encryption. So data encryption is important in terms of the backend as well as the front end. When you're sending data to the cloud, you should actually encrypt the data. And from the backend also, the data should be encrypted. And in terms of access control, this is where you give different access levels. Like my team's VP has a different access level than myself. So it's because people have different access levels and you can control. And this is actually good because let's say one of your employees leave and you want to cancel or revoke the access. What will happen? If you didn't have access control, he might even have access when he leaves the company. So that's a problem that people face. So access control gives that level of security for relevant levels in the software. And then, of course, you have monitoring and logging. In case you want to find out what happened last night, what happened when this user was using this software, you can simply use the logging systems available in the cloud. So these are just 9 threats, the very famous 9 threats. If I talk about these things, if you look at the very first one, data breaches. So these are considered as the top cloud threats that people face. The main one is data breaches, the nightmare of CIOs, where they fail to secure the data. If they are being breached, that's a big problem for the company. Second one is data loss. So as you can see, data has become the priority when it comes to cloud. And the third one is account or service traffic hijacking. As I said, sniffers who hijack in the middle, the man of the middle attack. So man in the middle attack. And then you have insecure interfaces. So I saw this instance in one of the companies that I worked in where you use a service, you use a set of APIs, but you need a token, you need a ticket to access it. So what they did was they used this ticket simply in the configuration file and uploaded it to GitHub. So the problem there is anyone who has access to their GitHub account, since GitHub is open source and So you can simply download that configuration file and get access to those APIs. So you should be very aware of whatever configuration settings you fix. And then, of course, denial of service, the DOS attacks. That has come as number 5 in cloud computing. Malicious insiders is the people who are actually working in the company and trying to access the data, or maybe send the data out. And then abuse of cloud services. So these are just basic things. When it goes down, it's like more general. Insufficient due diligence means lack of carefulness. And then shared technology vulnerabilities. So most of these cloud computing technologies are shared. So when they're shared, there are issues. So these things are also problems that people face when it comes to cloud computing. So we'll go through AWS cloud security a little bit because I want to touch this because I thought that it'll be interesting for everyone since you're working in AWS. So if we look at the shared responsibility, AWS does not protect anything that you use. What AWS has said is they protect whatever you do. So they give the protection for whatever you want. So if I explain this concept, there's a shared responsibility between the customer and AWS. What AWS does is they will give the security to the data center. They give security to the infrastructure, to the network, to the virtualizations that they provide for the hardware. They have a separate security. But other than that, AWS does not provide us security. What they provide is a set of tools. So you can simply use these tools and customize yourself and know how to use them. So if you look at an EC2 instance or maybe a S3 bucket, you have to specify your own security levels. They provide you security up to a certain level, but beyond that, it's all up to you to actually add a firewall, or maybe if you want to add a shield, or maybe a logging system, maybe IAM policies. It's all up to the user, to the customer, to take care of it. So basically, it's a shared responsibility. If you just search the shared responsibility model, that's what AWS has explained. They don't take care of the security. It's a shared responsibility between AWS and the customer. So these are just simple tools. So AWS has this thing called AWS Shield, where they mitigate or maybe stop distributed denial of service, DDoS attacks, which I was explaining before. So they have a separate shield that is connected with the ISPs, and they block whatever incoming request that comes in heavy loads. And then you have AWS Web Application Firewall. This is a simple firewall that they provide. This is provided free of charge, I guess. So this is like a way that they use to avoid unwanted packets coming in. Like they can stop SQL injection, cross-site scripting, and security concerns like that. And this is the famous IAM policies. This is the access control that AWS provides for the users. Even when you log into AWS for the first time, you will not be allowed to use your own account, the admin account. You will be asked, you will be requested to create IAM users or identity and access management users. So through that only you can access this whatever service you are wanting. So that is given through AWS IAM. This is also provided free of charge. So there are different tools when it comes to AWS. So what I wanted to highlight here was the concept of the shared model. There are different tools. Like if you go to the website, this link, you will see like 20 security tools that they provide. All of these come with the responsibility of the customer handling them correctly. So just one advice from me. Whenever you connect to the cloud, there's always a risk. So one of our lecturers actually said that when you upload a picture or a video, even a text to the cloud, it's gone. Even if you delete it, it's still gone. So you should be very careful before you upload anything. If you connect, that means you're connected. Whoever is waiting from the other side can hack into you. I know no one is going to hack us. But then again, if you are very important people, when we become great individuals in the industry, we should be very careful before putting check-ins and all these connections with the cloud. So thank you.